Hello guys, Actor here, and welcome to Derivatives. So this module got an update, which means that it accepts every valid answer as a derivative rather than a very specific answer required by a bunch of rules. So it's much more bearable now. So here's a tutorial for it then. So the basics of it, we need to solve the equations, which is getting the derivative, equal to the amount the bomb starting time in minutes divided by 3 rounded up. So I started this in Zen mode, but we calculate by 1, 2, 3, 4. 7 modules, doubled is 14. 14 divided by 3 is 4 and a bit. So we're going to be doing 5 questions. Wait, is it? Yeah. So we're going to be doing 5 questions for this one. Any incorrect answer for the question called a strike will still count over the equation. So even if you get one wrong, that still counts as completing a stage. So if, say I got this one wrong, it will still count as 1 out of 5. If we enter something that it doesn't know what it is, it'll flash red and won't give a strike, so it doesn't give you a strike for. If you have the right answer, you just typed in a weird way. We assume x is positive, which doesn't really come into play a lot, but in this case, it's just so this rule is probably a bit more neat. I'll get into these rules later if we don't get to cover some of them, but let's just get started. The main rule that we will need to know are these two here, are the ones I've seen classically appear, which is power rule, which is multiplied by the power, multiply the front of it by the power and any coefficient with it, and then reduce the power by 1. And then if we have an ln, we make it 1 over x, which, to tell you beforehand, if this is raised to a power, this x, that power replaces the 1 up here. I'll explain later why that's the case. So, minus 2 times minus 13 is positive 26. So we put 26. And then we don't actually have to put the star here, this is just for consistency. So x. And then subtracting 1 from minus 2 is minus 3, so it's going to be x to the power of, I'm going to put the brackets here, to the power of minus 3. If I can type properly. And then we're going to be subtracting 3 times 4 is 12. Then reducing the power, we'll get x to the 3rd. We press enter, and we complete our first question. Okay, so we do have an ln here, but this is raised to the 0th power. ln of 1 is 0. So this term goes away, so we only have to evaluate the first and the last one here. So minus 5 times 4. Minus 5 times 4 is minus 20. 20x raised to the power of 4 minus 1 is 3. Then we're going to be adding. So this is x to the power of 1, which if you know calculus, means we're just going to take the coefficient here, because we're going to be multiplying by 1 and then reducing by 1. X to the 0 is 1. So it's going to be 18 times 1 again. So this is our second answer, if I haven't done a stupid. Okay. Third one. 2 times negative 16, we have negative 32. X to the power of negative 17. Take away. Negative 18 times negative 32 is the same as 18 times 32, which is 576. And we're going to be adding that. X to the power of negative 33. Yes. Minus. Well, we've got minus again, so it's going to be plus again. 12 times 32 Well, actually, we could combine these terms. We don't need to simplify, but I'm actually going to here. So 5 times 6, and then 12 times 32 is 384. So I'm going to combine both of them. We get 960. That is the x to the power of negative 33. And we get another solved equation. Next one. Negative 2 times 17 is... Actually, we can combine these two again because the appended thing is the same. So, negative 17 minus 6 to be negative 23 times minus 2, which is 46, x to the power of minus 3. Okay, so we've got fractional powers here now. If you don't reduce the fractions, it's the same as 1 over 2, which will allow 1 over 2 as the power afterwards. So 5 times a half, or 5 times 2 over 4, if you will, is 5 over 2. X to the power, and then a half minus 1 is minus half. Next we have 7 times a quarter. That'll be minus 7 times a quarter even, which will be negative 7 over 4. X to the power 1 over 4 minus 1 is negative 3 over 4. And then finally, we're going to be doing 3 times minus 4, which is minus 12. And then it's going to be x to the power of minus 5. And solving that equation, we get a self-module. So I'm going to quickly solve this bond now. So I said I was going to explain the rest of these rules. So this is just what some people call this is what some people call the just like, actually I don't know what it's called, but this just basically says that the change in a constant as x increases is nothing. It doesn't change. So if you have like 17, for example, or 32 or pi, they all go to 0. This one we showed very often. We had an example of ln, but it was sort of a gimme one. So the top becomes the power because if you know rules logarithms, the power will come down to the front. So then it would just be this again, multiplied by a constant. So it'll be just 1 over x multiplied by the power, which is now the constant that you multiplied by. I don't know how common this one appears, if it even appears, but it's just a helpful little thing. And just to say, cosine, the derivative of cosine is negative sine, if that helps. This just says if you have an e to the x, which I don't know if you will need, because there's no e button on here, so you could completely ignore that one, I think. And sine isn't on here either, so these are just if you were wondering, I'm guessing. But these are definitely important. This just means evaluate each part separately, also for subtraction. These are basically the same thing, with the minus subbed in here. This is the product rule, just meaning that you would take the derivative of one and leave one as the other one as the same thing, and then you would do the same with those two rows flipped round, basically. And then the chain rule just basically says that you take the derivative of the function surrounding the other one that you're focused on, and then leave the inner function the same, and then you multiply by the derivative of said inner function. So this is quite a basic definition of how I've done it, but if you want a better description of some of these, I would suggest looking for actual math-based videos. But hopefully you understand how to solve a derivatives module now, and I'll see you guys in the next tutorial. See you later.